chaos. This is what the Node.js server code looked like before NestJS, and this is how it looks after using it. NestJS solves the problem of architecture. With NestJS we can create REST APIs and GraphQL APIs. We can add real-time functionalities using WebSockets, we can split our monolith into microservices, we can upload files, log the events, and integrate with ORMs such as Prisma. Decorators are used everywhere, and we can use them as guards useful for authentication and authorization to intercept and modify the request through interceptors, and we can also create validators that can validate and transform the requests through pipes. All these concepts and many more will be explained in the NestJS series that you can find in this playlist. Let's get started! NestJS is a progressive Node.js framework for building efficient, reliable, and scalable server-side applications with TypeScript. You've probably used Express.js or Fastify, which are web frameworks for Node.js. They are minimal, flexible, and provide a robust set of features for web and mobile applications, but there is no code organization standard. Superman comes to our rescue, hidden in the NestJS framework. Does that mean we have to forget what we have learned over time about Express.js? Of course not, because NestJS uses under the hood Express.js or optional Fastify. Nest provides a level of abstraction above these common Node.js frameworks, but also exposes their APIs directly to the developer. Without a proper architecture, developing and maintaining an application is a pain. The solution is to break it into smaller parts responsible for one thing. Nest calls these parts modules. Let's think about an e-commerce app where we can define a module for users, for orders, for chat, for any feature in our application. I hope you understand the decorators in TypeScript. If not, I have a tutorial on this topic. We install the NestJS CLI package. We can create a new project using the nest new command, which is the recommended way, followed by the project name. We open the browser at localhost on port 3000 and we see Hello World. That's great, it works. We are generating a new resource called questions that will create the necessary file structure for the efficient organization of the code. This is the method recommended by NestJS, especially for beginners. We create an array with two questions. How many minutes are in a day? The right answer is 1440. And what is the capital of Romania? The answer is Bucharest. We attach the metadata to the module class using the add_module decorator, and Nest can now easily reflect which controllers have to be mounted. The add_module decorator provides metadata that Nest makes use of to organize the application structure. Nest builds a graph of the application, and in this way it can solve the dependencies between the entities. The add_module decorator takes a single object whose properties describe the module. Providers, the providers that will be instantiated by the Nest injector and that may be shared at least across this module. Controllers, the set of controllers defined in this module which have to be instantiated. Imports, the list of imported modules that export the providers which are required in this module. Exports, the subset of providers that are provided by this module and should be available in other modules which import this module. In Nest, modules are singletons by default. The app controller is a class responsible for handling incoming requests and returning responses to the client. Decorators associate classes with required metadata and enable Nest to create a routing map. Controllers always belong to a module, which is why we include the controllers array within the add_module decorator. Hit the subscribe button, the bell, and we continue to analyze the controller. add_controller is the name of the decorator, and because it is called indicates that it's a factory of decorators. It allows us certain customizations and as parameters. The @getHTTP request method decorator before the getHello method tells Nest to create a handler for a specific endpoint for HTTP requests. We can use post, patch, and so on. The root path for handler is determined by concatenating the optional prefix declared for the controller and any path specified in the method's decorator. For example, if we add /greeting as an option for the controller, requests can be made to /greeting. The main idea of a provider is that it can be injected as dependency so we can create relationships between entities. Providers are plain JavaScript classes that are declared as providers in a module. One of the most frequent providers is the service class. Look Looking at the constructor's argument, we notice that the prefix is private. This syntax is a shortcut to allow us to both declare and initialize immediately in the same location. This is an injectable dependency. We tell the framework what dependency it will need to create at runtime. So, this type is very important to be specified. Nest will resolve the app service by creating and returning an instance. A DTO is an object that defines how the data will be sent over the network. To define a DTO, we create an interface or a class. NestJS recommends us to use classes because at runtime it has access to them and various features are available. We move to the questions controller, add a get request handler for the root questions greeting, and the language is a parameter. With the add request decorator, we can have access to the request with IP to IP, and with param we can specify in parentheses an argument, the name of the parameter, and define the variable where we want the Nest to put the result. For example, the string language. A client makes an HTTP request and the root handler will process it. A middleware is between the two. Middleware is a function which is called before the root handler. A middleware must implement the Nest middleware interface and write the logic inside the use handler which have access to the request, response, and the next middleware function in the application's request-response cycle. By default, the NestJS middleware and Express.js are the same. Middleware functions can perform the following tasks: execute any code, make changes to the request and the response objects and the request-response cycle, call the next middleware function in the stack, and if the current middleware function does not end the request-response cycle, it must call next to pass the control to the next middleware function. Otherwise, the request will be left hanging. Modules that include middleware have to implement the Nest module interface and apply it for controllers or routes in the configure handler, which has a middleware consumer argument. In order to facilitate the writing of some generic guards, filters, and interceptors, NestJS offers us some utility classes. Two of them are arguments host and execution context. Arguments host simply acts as an abstraction over a handler's arguments. For example, for HTTP server applications, the host object encapsulates expresses array, which contains request, response, and next. For GraphQL applications, the host object contains the root, args, context, info, all as an array. An execution context extends arguments host, providing additional details about the current execution process. Nest comes with a built-in exceptions layer which is responsible for processing all unhandled exceptions across an application. When an exception is not handled by your application code, it is called by this layer, which then automatically sends an appropriate user-friendly response. An exception class must implement the exception filter interface. We get the context using host.switch to HTTP, and from the context we have access to the response and request objects. This custom exception wrapper adds a timestamp to the exception so we can know when this problem happened and also for which URL. We can test it by using the add_use_filters decorator by throwing a dummy exception. There are plenty of useful built-in HTTP exceptions. The full list is in the description. A pipe is a class annotated with the @injectable decorator. Pipes should implement the PipeTransform interface. So, under the pipe can hide a validator. Pipes have two typical use cases. Transformation, transform input data to the desired form, for example from string to integer. And validation. Evaluate input data and if valid, simply pass it through unchanged, otherwise throw an exception when the data is incorrect. If there is no meta type or it's a primitive type, we return the received value. If the condition above is not true, the execution will continue to validate the value against some rules defined by us. If there are validation errors, those will be present in the errors and we can throw a bad request exception with the message validation failed. The pipe receives the arguments designated for the method and operates on them. After transformation or validation, the root handler is invoked with the transformed arguments. The pipes all work in the context of validating root parameters, query strings parameters, and request body values. Nest comes with 8 pipes available out of the box. Authentication authorization are very important for any application, and in traditional Express applications, middlewares are used. But the problem with middlewares is that they don't know which handler will be executed, they don't have an execution context like guards. So middlewares are stupider than guards. Guards are executed after each middleware, but before any interceptor or pipe. Please provide us with proof that you are logged in. I can't. Alright, then we don't let the root handler run. Guards returns true or false, and depending on these values, the execution of the handler is allowed or not. What is an interceptor? We will see soon. The simple auth guard implements the canActivate interface, and the canActivate method receives the execution context. The logic inside can be very complex, but for now we use the validate request method, which will return the hard-coded value is valid. You should put your logic inside this function and return the appropriate true or false. We will complex logic in the next episodes of this series. Another very useful guard is one that defines some roles. Each interceptor implements the intercept method, which takes 2 arguments. The first one is the execution context instance, and the second is a call handler. The call handler interface implements the handle method, which we can use to invoke the root handler method at some point in our interceptor. Handle returns an observable. We can intercept the request and return an object with a top-level property called data. Interceptors can bind extra logic before after method execution, transform the result returned from a function, transform the exception thrown from a function, extend the basic function behavior, and completely override the function depending on specific conditions. As a bonus, I used Webpack for hot reloading. I'm not going into the configuration details because it would take too long, but the following packages will need to be installed and a file named webpack html.config.js created. You'll find the code in the description. We also add the necessary configuration in main.ts. We replace the start dev script, which through the watch flag tracks changes in the file, which is almost similar to what we can achieve using Webpack. NestJS is awesome. Give it a try and tell me in the comment section your thoughts. I invite you to subscribe, like and share to learn programming fast. Activate notifications by clicking on the bell. Thanks for watching.